Hello, everyone. Thank you so much for coming. I may have been singing quite loudly along with the line breakers last night, so my voice seems to be suffering a little bit this morning, so apologies in advance if it disappears halfway through this talk. But yeah, thank you so much for being here. My name is Jo Franchetti, and I am a developer advocate, currently unemployed. So if you enjoy this talk, consider hiring me. Today, I would like to talk to you about the importance of developer experience. So let's start with a story to illustrate what developer experience actually is. So you are a software developer, and you've been asked to integrate with a new developer tool. Let's call it codemajig. And someone that you work with has told you that codemajig has been recommended for its advanced features and its time-saving capabilities. And you're excited about the potential that codemajig offers, so you embark upon the journey of onboarding with codemajig. And you start with the obvious thing. You open up your favorite search engine and you try and find online tutorials and documentation to understand the basics of codemajig. However, you quickly realize that there aren't actually very many available resources, and the ones that are available are quite poorly structured. The official documentation is incomplete, it's outdated in places, it lacks clear examples, and it doesn't give you good use cases. And you have found some tutorials, but they're either overly simplified or they're overcomplicated and they skip over steps, and it leaves you feeling frustrated. But you're determined to overcome this setback, so you reach out to the codemajig community to get some assistance. You join their online forum, their Discord, and you hope that you can find guidance from their experienced users. But unfortunately, the community turns out to be quite unresponsive and also unwelcoming to newcomers, so your questions go unanswered for weeks. But you're a consummate professional. You decide that you don't need the community. You can experiment with this code yourself. You're going to work on a small project. But you quickly discover there's a very steep learning curve. The code base is complex, it lacks structure, and it's just challenging to navigate and find out the features of this tool. It doesn't have proper error handling, it doesn't have good test coverage, and you get these sort of cryptic error messages that don't help you to understand what is happening when you're troubleshooting. You find lots of bugs and inconsistencies with the tool, and being the helpful community developer that you are, you report these back to codemajig, but you get no response. Your issue just sits there untouched for days. And as the weeks turn into months, your enthusiasm for codemajig wanes, and you start to question why the decision has been made to use this tool. It lacks learning resources, it has an unhelpful community, it has inherent flaws, and it's just frustrating and demoralizing to use. You decide that despite all these promising features, codemajig has such a poor developer experience, a lack of support, and technical issues. It's just impossible to use, it's impossible to fully leverage. Ultimately, you and your team decide to abandon codemajig and go with a different tool altogether, one that offers better documentation, better community support, and a much shallower learning curve. So we say bye-bye to codemajig. You have lost a customer because of your poor developer experience. And I'm sure a lot of you have experienced this kind of onboarding journey with tools. This experience with be it a new tool, a framework, a language, this first experience that you have is going to be the deciding factor of whether or not you continue to use this, whether you decide to become an advocate for it and convince other people that they enjoy it. And it's going to sway developers as to how they experience the quality of the products that you're building. And developer experience, or DevX as it's often written, oh gosh, my voice is going already, describes the journey that a developer takes as they onboard and use your code. It's the lived experience of developers and the points of friction that they encounter as they work with the things that you are writing. And developer experience isn't just at that getting started stage. It goes all the way through, building, testing, debugging, releasing products with the things that you're writing. And as developers who are writing code, even if you do manage to get someone to onboard onto your product, the tools that you're building have to have a pleasant developer experience, or you're going to lose them in the future. The moment they see something that looks better, that has better support, that's easier to work with, they are going to jump ship. Poor developer experience will cost you money, it'll ruin your customer base, and damage your reputation. And a common misconception is that DevX is only the tools themselves or the products themselves, but research shows that there are actually human factors involved as well. So things like having clear goals, having easy step-by-step guides, feeling like you psychologically are competent and can deal with this code base can make a huge difference to the developer experience. So let's take a deeper dive into what can affect developer experience. Then I'll give some examples of how we can measure developer experience. And then I'll give some examples of things that I've seen out in the wild that I think that we can improve. So there was a recently released paper by the Association for Computing Machinery on developer productivity. And they break down this idea of developer experience into 3 segments. So we have cognitive load, we have flow state, and we have feedback loops. And when we consider these all together, these 3 factors describe the full range of friction types that can be encountered by developers as they work with your code. So let's take a brief look at each of these. As I'm sure you're all aware, software development can sometimes be quite difficult. It's complex, it's complicated, there are always new tools, new languages, new frameworks, new methodologies to learn, and writing and reading and learning code all contribute to a workload in your brain, and this is called the cognitive load. And cognitive load refers to how much information a developer requires in order to process a task, in order to complete a task, alongside how much other stuff is happening at the same time in their heads. So it's how much effort it's going to take them to learn and to retain information. And psychologists often refer to this as something called the working memory. And it's how much capacity your brain has to hold information temporarily. And it actually works very similar to how the RAM in your computer works. So you have a certain amount of fast access storage, which you start to fill up as you're doing tasks. And at some point, your cognitive capacity will be full, and you will either have to stop doing something or forget about something when you want to do something new, or you're going to start to make mistakes. You're going to start to see errors occurring, and you'll find yourself slowing down the more things you try and pick up. And cognitive load increases as the things that we're doing become more difficult or more complex. So things like learning something completely new takes quite a lot of cognitive load. But it can also be increased by extraneous information processing while we're trying to do a task. So unfortunately, things like trying to multitask actually can massively increase our cognitive load. Working in a noisy environment or working with a lot of different things happening on your screen at once can all increase your cognitive load. Or if people are asking you to switch tasks, so you're constantly holding something in short-term memory. Things like poor documentation, where you're searching and trying to get through a lot of different things at once. Too much instruction, too little instruction, badly designed tasks that don't allow you to flow from one step to another, these can all affect your cognitive load. And feeling anxious or feeling bored, or if you're overtired, these can all decrease your the working memory that you have available and therefore increase the cognitive load. And when cognitive load is high, you're going to have to put a lot more effort into retaining the information that you're reading, a lot more effort into achieving the goals that you're trying to achieve. And you're more likely to make mistakes, and you're less likely to be innovative when your cognitive load is high. So it's really important that we consider this when we are coding, when we are making tools. We want to improve the developer experience as much as possible to reduce the cognitive load on the developers that are using our products. We should be finding ways to eliminate unnecessary hurdles in the process of onboarding developers. We should be creating well-organized code bases. We should be creating great documentation. We should be making sure that we are setting easy tasks to follow that are step by step. And dedicated DevX teams can provide things like easy-to-use self-service tools. They can help streamline your documentation, make sure that it's always up to date. And of course, this is not only for people who are onboarding, but this is for those who are well-established as well and who are bug fixing, who need things like useful error messages that link to FAQs, that kind of thing. And consider presenting the information that you're giving these developers to help them with onboarding in different forms. People learn in different ways, and so presenting things like written documentation, maybe a video, maybe a step-by-step guide, maybe a fully fledged demo that they can just dive into and see the code. These are all going to make your tool, your code base more accessible. Allow developers to use the tools that work best for them. Because when cognitive load is well managed, developers find it much easier to be efficient and to be productive. And it allows for something called flow state to happen. And I'm sure you've heard people say things like, oh, I'm really in the zone. That idea of being in the zone is when you are in flow state. And sometimes people will say like, oh, I was just in the zone and then I had to jump into a meeting. And that's when the flow state has been interrupted. And flow state is a mental disposition where a person is fully immersed in the activity that they're performing. It feels really enjoyable being in flow state. It's quite energizing. You feel more creative. You feel more productive. You feel motivated, and you're actually more efficient when you're in flow state. You find it much easier to retain information, much easier to fix problems, much easier to come up with innovative solutions. And it's an enjoyable feeling, and it can lead developers to perform better and to produce better products. So it stands to reason that we want to create an environment that allows for flow state. So in order to do this, there's a few things that we can do. Firstly, we need to make sure that the skill level and the challenge that we're presenting are well balanced. So tasks should present enough of a challenge that the developer is interested, their mind is engaged, they're in a problem-solving space, but they're not confused or frustrated, they're not overwhelmed. Too much challenge can leave you feeling belittled, it can leave you feeling foolish, and it can start a feeling of anxiety, and you start to sort of scrabble, and suddenly that flow is completely gone. I remember once my dad called me, and he was like, my computer's broken. And I asked him, well, why didn't you just, you have the entire internet at your disposal, why didn't you look up a fix before you called me? And his response was, if he spent, say, 2 hours Googling for a fix, he might spend 2 hours trying to fix his computer, and at the end of it, he wasn't sure whether he'd have a fixed computer or not. His skill level did not match the challenge that was in front of him, but he knew if he called me and I looked up a fix, I'd probably be able to, within the 2 hours, find a fix the computer, would know the computer was fixed. He gave up before he'd even started because his skill level was just not great enough to match the challenge. And we want to be creating confidence in developers that they're going to be able to use these tools, to understand them, to onboard. And getting this balance of challenge and skill is when you really allow developers to feel like they're in control of the process. And we can do this, so that the skill level challenge balance, we can do this by setting clearly defined tasks and achievable goals as we're helping them onboard. So, we give them clear installation steps. We give them code demos so that they can take it and run it and see something happen. Completing tasks gives a developer a sense of achievement and makes them more likely to want to pick up the next task and the next task. And conversely, things like interruptions and delays are going to hinder your flow state. So anytime you struggle to find information, you might find yourself sort of, you need to swap from your IDE to your browser, and suddenly you've opened your browser, and then you've seen that you've got an email, and then you've responded to that email, you've answered something on Slack, you completely forgot what you were doing in your IDE, you have to go back and re-immerse yourself. We really don't want to be putting out these, so the way I think of it is your developer's like a sprinter, and they're running on a sprinting track, and every time you have a problem like a bug in your software or some documentation that doesn't explain something or an error message that doesn't help them, it's like you've just thrown a brick out in front of that sprinter and they've tripped over it. And now they have to get back up again and start sprinting again. And every time there's a brick, it takes them more energy to get back up again. So we want to be removing these bricks as fast as possible. Switching between tasks, getting lost and frustrated or distracted reduces the focus the developer has and makes it more likely that they're just going to give up. They're going to do something else. So if you've ever found yourself doing things like checking your email or doing admin type tasks when you're overtired or when you're frustrated with a project or you've got a problem that just you can't find an answer to, it's because you don't want to face that mental hurdle. You don't have the energy required to stand up after that brick and start sprinting again. A flow state absolutely depends on developers having the autonomy and the opportunity to work on fulfilling challenges that give them tasks that they want to do next. And the best way to find out whether or not we're getting this challenge and skill level right is by asking for feedback, getting feedback from the developers that are using our products, and also giving feedback to them so that they know whether they've done something right, whether they have understood a task. And so that brings us nicely onto feedback loops. And it feels like a really obvious thing to say, but meaningful feedback loops between developers and developer effort and impact is central to developer experience. How can we know that we're doing a good job, that we're creating a good developer experience without getting feedback from the developers who are using our tools? Feedback allows us to find where we've made mistakes. It allows us to learn and improve, and it fosters a feeling of visibility amongst the developer community. So if they're giving us feedback and we're acting on it, it makes them feel like we care about what they think. We care that they care about our products. And it will allow us to discover where developers are struggling, where we've accidentally put those bricks out, and where their cognitive load is becoming too much. And this is ultimately going to lead us to build more beloved products, which is what we want to do. And we should also be looking to provide feedback to developers while they're using our products. Getting feedback to them quickly while they're working is absolutely imperative to maintaining that flow state. I'm sure this is something you've all felt yourselves when you have good test coverage, for example, and you get that immediate green and you're like, cool, that's that, I can move on to the next thing. We should have things like continuous integration so that they can run their tests and get working immediately without having to, open up a browser or whatever it is. They should be able to stay in their IDE, stay focused, stay on task. And we can do things like offer steps in a tutorial so that they can have a load of tick boxes so they can say, cool, I'm moving forwards, I'm getting through each thing. Providing slow feedback or no feedback will leave developers in the dark. It'll lead them to have increased cognitive load and a reduced flow state. And feedback could be an entire talk in itself. So if you're wanting to learn more, there's actually a tiny little link down at the bottom there, and I will share these slides out at the end. But that's an excellent article by Tim Cochran, who's the technical director of ThoughtWorks, who talks about feedback loops and how to implement them. So The eternal question when we're talking about developer experience is, how do I know that I have made a difference? How do I know that the changes that I made are improvements? And in order to know where you stand currently, you need to be measuring. And then you can know whether or not you're making a positive change. And the question of what to actually measure with DX is a difficult one. And I hate to say it, but the answer is kind of, it depends. DX encompasses so many different aspects, it's quite challenging to quantify, but these are some common things that you can measure that I would recommend you consider measuring. So firstly, get feedback. As I've mentioned already, you can conduct surveys, you can be checking your GitHub for issues, and you can use these to understand customer satisfaction and whether your customers have any particular pain points. There's also things like Net Promoter Score, which will tell you whether or not your customers would recommend you to somebody else, and CSAT, which is the customer satisfaction score, which tells you how your customers feel about the point that they decide to pay for your product. So maybe they've moved from a free tier to a paid tier. Like, what were they thinking at that time? Why did they make that decision? How is that going to help you get more developers through that pipeline? And you can track your internal team as well. So do regular check-ins with your developers to give you an idea of where they think improvements can be made in your internal teams. And it's a really sad metric, but also track employee turnover. It's vital to get that information at exit interview. If your employees are leaving, you need to know why, and you need to know what isn't working for them. We can use code quality metrics such as code review feedback. So this is something you should be tracking. Things like code complexity, code coverage, and you can even count things like the numbers of bugs that are reported, the numbers of GitHub issues that you have. And you want to track these over time to see if the DX changes that you're making are having the desired effect, hopefully reducing code complexity, increasing code coverage, reducing the number of bugs. And we should also be thinking about things like documentation quality here. So evaluate how much your documentation covers your code base, how many demos you have, how many comments are there in your code. Regularly make sure that your documentation is up to date and trim out any that is old or is misleading. And then we can do things like measure KPIs, we can measure burn down charts, which is the number of completed story points, the number of features that you've managed to deliver over a period of time. This will help you understand about your team's productivity and whether or not they're struggling, like whether your internal developer experience is stopping your developers from being as productive as they could be. And there's an absolutely incredible research paper by Kat Hicks and her team over at Pluralsight, which measures developer productivity and developer thriving. And I highly recommend that you check that out. It really talks about how we can improve that internal developer experience. And you can assess things like communication within your teams. So how frequently are people in meetings? How many hours are they spending in meetings? How much time do they have to spend on email? Are they getting knocked out of the flow because they're constantly on email or they're constantly on Slack? Get a good idea of what times of day your developers are working and for how many hours. It's a good indication that your developers, that your team might be heading towards burnout if you see them sending emails or messages, at nighttime or early in the morning. And also measure things like participation in training programs or certifications and skill development. Make sure that your team is given the time to develop their skills. They don't want to be keeping their nose to the grindstone all day. They have to be developing themselves as well to feel like they are in an environment that cares about them. And then there's the development cycle itself. So we can take time to see how long it takes to get from an idea to building a product. Shorter development cycles usually imply a smoother development process. So we want to measure the time that is spent debugging versus building features. We can track how frequently code changes are deployed to production. A high deployment frequency suggests that we've got an efficient development and release process. And remember that DX is multifaceted. You're going to have to consider a whole lot of quantitative and qualitative metrics to get a full understanding of your DX. And this is going to be very personal for each of your own projects. So you're going to have to make some decisions about which of these metrics you need to track. But regularly collecting and analyzing these metrics is going to be absolutely vital for making improvements. You can't know whether you're doing the right things unless you're measuring. And the overarching goal of DX is to provide a smooth and efficient environment for developers. And DX, I tend to think of it split into two separate areas. So on the one hand, we have our internal developer experience. So this is the people that we work with directly, who are on our teams, who are working with us in the same company or on the same project. And on the other hand, we have external developer experience. So these are the developers that you may never meet in person, the ones who are using your products. And it's obviously going to be much easier for you to define your internal DX because you know these people, you can talk to them. Your external developer experience is going to require a lot more research. You're going to have to make some assumptions about who they are, about who you want them to be, who you want to reach, what their skill set is, and then you can start to, once you've got an idea of who they are, provide the right guidelines for them, the right steps, the right improvements. And of course, you're all going to interpret the information in this talk and make it relevant for your own teams and products, but I'd like to also give you some practical takeaways. And these are things that I've seen that I think reduce cognitive load and help keep developers in the zone. So we're going to start with the absolute basics. So we'll start with our code bases. So these are some standard hygiene practices that seem obvious when you see them written out like this, but I have seen some things out there, and so we're going to go over each one and talk about how it can make a difference to your developer experience. So firstly, a good code base follows the default language convention of the language that you are working in at the time. And anything that deviates from these standards, no matter how clever you think you're being or how well-intentioned you are, it's going to increase the cognitive load on the developer. Every change that you make from the standard, you're just putting more bricks out in front of your sprinter. There's going to be surprises for them. And remember also that every new tool that you include, every dependency that you include, you're just raising that bar to entry again. It's another thing for them to learn. It's another little brick for them to potentially trip over. I may be preaching to the choir here, but you can reduce time spent onboarding by making use of dev containers and codespaces. And if you aren't familiar with them, containers are lightweight packages that contain your entire application code together with its dependencies, and they create a full developer environment with minimal setup. So your developers will no longer need complicated dependency installation or fears about platform compatibility. GitHub offers code spaces that you can run either in the browser or in VS Code. And VS Code actually has a containers extension as well. So you can use a container as your full-time development environment, which just allows developers to get started so much quicker, taking those bricks away. And if you can't use a dev container, please at least try and avoid global dependencies if you can. It just makes it that bit easier for developers to reproduce your projects. And it helps maintain the integrity and the stability across different setups. I'm a Windows user. I fall foul of this all the time. And if you can't avoid external dependencies, then please consider scripting them. So for your JavaScript users, you can put some scripts in your package.json and then execute them with yarn or npm. And these scripts are going to run those global dependencies installations for you. But remember the gotcha, again, these commands will differ between Mac and Windows, so please consider us Windows users. We love you. The next thing to talk about is your README. It serves as the initial point of contact for any developers who are using your code. It's their introduction to you as a developer. It's their introduction to how you think, to why you built this, to why you care about it. It's their introduction to you as a writer and a human. It helps them to understand what your project is about, why you built it, why they should be interested in it. And a well-crafted README can massively improve the developer experience, enhance the accessibility, the usability of your products. So invest time in writing a comprehensive README. It might feel like an annoyance. You've finished your project now, you're ready to release it, and now you've got to write an essay about why you made it. But it helps communicate the value of the thing that you've built, and it helps to foster engagement. So these are a few things that I want to see when I open a new project and look at its README. So first up, if the README is long, I really appreciate a table of contents at the top so that I can jump to where I need to be. There are generators online to make these contents for you. VS Code also has an extension that'll make it for you based on your headings. Start the README with a brief introduction to your project. So describe its purpose, what the goals are, what the key features are. And then I want to know how to use your project. So what do I need in order to run it? For example, what version of Node do I need? How do I build it? How do I run it? Give me some nice commands that I can just copy and paste as code snippets so that I can get going immediately. Really hold my hand through this. Give me a usage guide, provide instructions on how to use your project, explain the main functionalities, and include code samples, include usage scenarios. And let me know if there is any configuration needed. Give details on how I can configure, how I can customize, and give me example configuration files, again, that I can just copy and paste. Give me actual code snippets of the configuration with your ID here or whatever it is. Let me know the project's constraints. So are there any particular gotchas? Are there any bricks that I should look out for? Because if I know about them ahead of time, I can just jump over them. Don't leave me guessing about why you made the decisions that you made in this project. And there are other things that you can also add to your README, or you can add them as separate Markdown documents. So guidelines for contribution are really important. We want developers to be engaging. We want them to be giving us feedback. So explain how they can contribute, how they run the tests, how you want bug reports submitted, how they can propose enhancements, any specifically required coding styles that you expect, any linting rules you expect them to follow, any testing frameworks that you're using. Make it as easy as possible for contributions, and you will get them. Provide contact details, so if they find something but they don't want to make a contribution, how can they contact you and ask you about it? How can they get help from your community? Make sure you include a code of conduct, and this will explain the behavior that you expect from your community and the behavior that you expect from the people who are contributing, and what will happen if there is a violation of that code of conduct, so how you're going to handle it. And also any restrictions or requirements of using, modifying, or distributing your code should be in a licensed document. And a well-written README, as I said, just massively improves the clarity, the usability, the overall quality of your project, and just really is going to help improve that developer experience. Good technical writing can make a huge difference to your README, to your documentation, to your tutorials, to your blog posts. What you're doing with technical writing is you're taking what is quite a complex topic and you're breaking it down and making it accessible, making it digestible. And an important component of good technical writing is understanding who you're writing for, so getting to know your audience. Start the writing process. Before you even start writing, consider who the reader is. So what is their technical expertise? What is their role and their responsibility? Are they beginners? Are they experts? Once you've identified who they are, maybe consider creating a persona for them. So, this is Fred. Fred is a CTO. This is George. George is a beginner developer. And what those people want from the documentation is going to be different. The CTO wants to know why this product exists and why they're being made to pay for it. And George wants to know how he can fix this bug that he's found. Assign them a whole background, a name, a story, an understanding of why they're reading this document. And then when you're writing, you can write with them in mind. Make sure that you're using simple, direct language that is going to convey your message as clearly and concisely as possible. Keep a consistent tone of voice, consistent use of tenses. I know this all feels obvious, but I have seen the readmes that are out there. Write low complexity sentences. Keep your vocabulary low complexity as well. Keep your paragraph short. Give frequent examples. Focus on readability and accessibility. So use things like headings to convey the hierarchy of the document. Use descriptive link text. And of course, give your images descriptive alt text as well. Use inclusive language. So think about the ability-specific language that you're using, and I see this a lot. Use things like read instead of see, or check out instead of look at. And try not to refer to things as crazy or dumb. Try wild or baffling. There's no need to be using ableist language, to be using gendered language in your writing. We have a bunch of neutral pronouns that we can use. We can use things like work hours instead of man hours, or staffing instead of manning. And avoid things like idioms or slang when you're writing, because these can confuse people whose first language isn't the same language that you are writing in. And try and avoid as much as possible saying that a step is easy or that it's simple, like, oh, simply do this, or you can easily do this. If the developer then has a problem following that simple step, that easy step, they feel belittled, they feel like they've fallen at the first brick, basically, and they're just going to get up, turn around. So don't make them feel belittled. Many of us have a short attention span these days. I know I certainly do. Big chunks of text. If I see a big wall of text, my brain just slides off it like Teflon. So try and break up big walls of text with illustrations, with graphics that are going to add to your point. And this also helps engage people who don't connect well with written words, who would rather learn through pictures, through diagrams. Much of your audience might be visual learners, so accommodate these people with functional imagery. And finally, consider different learning styles, as I mentioned earlier. So not everybody wants to read. Some people may want to watch a video or listen to audio. Some people will want a step-by-step tutorial. Some people will want a fully functional demo that they can just look at the code. They don't even want to read your step-by-step. And the final thing that I want to talk about today is the code itself. So these are just a few things that I've seen that I think can make a difference to your developer experience, because we spend the majority of our time with code reading it rather than writing it. And we've all seen illegible code bases. When you're writing code that others are going to read, it's really important that the code that you write is clear and concise and gets your point across. You're writing it with an intention of somebody else reading it and understanding it. And this person who's reading it, you're likely not going to be able to get a chance to talk to them. You're not going to be able to explain yourself, explain why you did these things. So your code needs to be self-explanatory. Your code should be unsurprising to the reader and lowering the cognitive load as much as possible, allowing them to stay in that flow state. So, first thing I like to see is functions without side effects, functions that do one thing and one thing only, pure functions, they're easier to read, they're solely dependent on themselves, they're not going to affect any external state. And it means, by doing this, that your readers have less head compute. They can look at that function, they can say, okay, that function does that thing. I now understand what that does. I move on to the next one. I don't need to keep it in my head. I don't need to keep thinking about what this thing does. Functions with fewer arguments are generally easier to read and easier to comprehend. And if you really struggle with this, try and refactor your functions to make them smaller so that you can reduce the amount of arguments. When you look at a code base that has, a huge amount of arguments in your functions, it just, again, it immediately starts, the panic sets in and you're like, oh, I've got to remember all of these things. I've got to understand what each of these things needs to do before I can understand what this function does. You're knocking that developer out of the flow state. Promises are more readable than callbacks. So instead of nested callbacks, try and use promises. They make it easier to see the linear flow of progression through your code, and they result in more concise code blocks. And they're just going to help the developers understand the flow of the asynchronous operations. And again, going to reduce the cognitive load. If they can read your code and understand what is happening at each step, it's going to help them stay in the flow state for longer. Return early and often. So place early return statements at the beginning of your functions or your methods. This is going to immediately communicate the conditions under which the function should exit. So this, again, we're reducing the need for the developer to hold things in their head. They can understand, okay, it's going to exit here. I don't even need to read the rest of it. Or I need to read that next little bit and then it's going to exit there. Okay, great. It minimizes the need for the dev to hold multiple conditional branches in their heads while they're reading your code. Avoid the pyramid of shame, so nested if statements. As the nesting level increases, it's more convoluted, it's more difficult to follow what has happened. They're much more likely to make mistakes. There's much more likely to be a bug in your code. It's harder to follow the logic of what is happening. Pyramid of shame leads to bugs, maintenance issues, and increased cognitive load. And try and use descriptive language when you're naming your functions, instead of using abbreviations, longer function names actually make it easier to understand what the function does. Like, tell me what the function does as its name. Make your code self-commenting. Then, we don't need a bunch of comments that are going to break up the flow of the code because I'm reading it like a novel. It's telling me the story of what it does. The goal of writing clear code is that you can read it and you can understand what it is doing. You may be tempted to write comments. Comments, to quote Mr. Whitney sat in the front here, are either lies now or lies in the future. Somebody at some point is going to come in, edit the code, forget to edit your comment. It's going to get out of date really quickly. And yes, we've all committed cardinal sins in our code and had to put a little comment in to say, like, this is why this thing does this thing. And I'm not saying don't put any comments in, but use them sparingly. As I mentioned, use your descriptive naming to explain what your code is doing, and use your comments to explain why it is doing what it is doing rather than what it is doing. And now, time to make some Vim users really angry. So I really like long lines in my code. When I'm writing code that is for educational purposes, so when I'm writing to explain how to do something, when I'm writing to explain a new methodology, when I'm writing to explain what this library does, I find long lines of code are a tool that we can use to make our code more readable and more legible and more understandable. And I see you all like panicking in 80-character linting, but I'm going to show you an example that I hope will maybe change your mind. Let's see. So we've got some code here. I hope you can see. And if you can't see, concentrate on the shape of the code. And I'm sorry for bringing TypeScript to a .NET conference. So this is from an SDK that I wrote recently. And it's an endpoint that returns artist data. And I think that this code is well written, judging by the comments that I just made. So the class and the functions are nicely named. We have a class called artist endpoints, a function, albums, top tracks, related artists. I can start to make guesses about what this does before I've even looked at the code. The functions do only one thing. And yes, there is a comment in there, and it explains an anomaly that is happening in the code. So it says bug, market is flagged as optional in the docs, but it's actually required for this endpoint. So I found a bug. I will later update the docs, but that's not how it works at the moment. So this is a gotcha. And yes, there are a lot of parameters. Unfortunately, this particular API has a bunch of different options. But what I've done is I've put these parameters all onto one line. And I think that doing so reduces the cognitive impact. What I'm saying is I'm pushing all that information over to the right-hand side. And usually developers aren't sort of looking at the right-hand side. So I'm saying, you can kind of ignore this. This isn't information that you need to know just yet. You don't need to retain and remember every single one of these parameters. Skip over that and look at what's happening inside this function instead. Vertical space, it means something. When we're reading a book, when we're reading a novel, a new paragraph implies perhaps a new concept or something new is happening within the story. If we start putting things on new lines, we're implying that there's some new concept happening, that there's some significance happening. A line break suggests a new section of code, be it, a new functional block, a new piece of logic, and it can actually, I think, distract from cognition. Our brains think that there's something separate happening and will try and parse. So let's take this beautiful code here and run it through an 80-character linter and see what comes out. So this is what we get. And I don't know about you, but just looking at that immediately, I feel less cognition instantly. It's like hitting return halfway through a written sentence. It suddenly is breaking in places where I don't expect it to. So let's take a closer look. Let's start right at the top of this file here. Have I got a cursor? Yeah, so let's start up here. So even the imports, all of a sudden, I've got to read through each of these imports. So we're importing artist, market, max int page. There's a whole bunch of things there that I'm suddenly like, what are these things? Do I need to know what these things are before I can even look at this file? All I'm doing here is importing these things because I need to satisfy JavaScript's module system. Like, these are not important for the developer to understand, but suddenly they've pushed the code that I actually want the developer to read all the way down to, what is that, line 9 or something like that? It's just it's extraneous information they don't need to care about. And yeah, you can see in the original formatting, it's on line 3. We're adding cognitive load by doing this. And also, it's removed my white space. So I had white space here between the class definition and the code inside the class, because I think that space was helpful to delineate, here we are, here's the class, here's the functions on the class. They are separate concepts. it's like a writer not using a paragraph when they finished one concept and started another. Like, I think that space helps your brain have a little bit of a breathe and understand what is happening next. So the next block of code is mostly unadulterated. We've ended up, what have we got here? Yeah, so we've got here on our albums, dropping each of these parameters onto a new line has, again, it's forced us to read all of them. So suddenly, even these ones that are optional, like I really don't need to care about these, but suddenly I'm reading them. Not only that, it's changed the shape of the function. Like, I know function name, parenthesis, curly brackets. That's the shape that I'm expecting. But suddenly I've got this parenthesis and this stuff is all on a new line. Then the parenthesis, curly brackets has its own line because that's important. It feels like we're lending importance to things that aren't the things that we want the coders to read. They aren't the things that we want the coders to think about. I'm forced into comprehending something that should have been much simpler. And then if we take a look, the top tracks here, so the return here has been split up so that we can give this bracket semicolon its own line, because that was really important. It's ruined the shape of it. It's changed it into something that isn't immediately recognizable. It's increasing my cognitive load. It's putting bricks out and confusing developers. And this is something that I think we all really need to consider when we're writing code to explain something, when we're writing code for educational purposes, when we're writing code that somebody else is going to come along and read. And I'm sorry to Vim users, I'm sorry to people who love ESLint, I'm sorry to people who do use your 80 character linters. We have wide screens these days. We're not all working in IDEs that are this wide. And even if we are, maybe that's a good thing. Pushing that stuff out to the right, where they actually have to scroll to read it, is even more like saying, this stuff doesn't really matter. Don't think about it. You don't need to head compute this at the moment. It's not 1996. We have nice widescreen monitors. Let's consider the legibility and the readability of our code a little bit more. Let's think about our readers and let's try and improve our developer experience. So I guess what I'm trying to say is, my name is Jo Franchetti and I love long lines. And that is the end of my rant. So we have talked about what makes up developer experience, what the human aspects are, what we can measure to improve our developer experience, and things that I have seen that I think improve developer experience. If you would like to get any of the links, you can absolutely do so using that QR code. I will share the slides out on Twitter. But thank you so much for listening. I won't do questions, but come chat to me if you have any. I'd love to.